So I'm supposed to be working on my UWorld right now, but for the past day I've been having really serious connectivity problems. I blame my ISP for that. Hey everybody, welcome to JuanMD. My name's Juan, I'm an MD, and on JuanMD I talk all about living life as a doctor, doing doctor stuff, taking care of patients, studying, and making the most of my Juan life to live. So I've been putting this project on the back burner for now, but since I don't have any internet today, maybe I could get to work on it. I'm going to be talking about the heme synthesis pathway, particularly about Porphyrias. Heme synthesis begins with a molecule called succinyl-CoA. It combines with glycine, and with the help of vitamin B6, it goes out of the mitochondria. It goes through a series of steps back into the mitochondria, combines with iron, and turns into heme. Heme, when combined with proteins, turns into that machine of a molecule that takes oxygen and carries all throughout our body. Now, the heme synthesis pathway is comprised of a series of steps, and with each step, anything can happen. The recurring theme of biochemistry, after all in medicine, is essentially Murphy's Law. So without further ado, let's do some drawing as I talk about the Porphyrias. So actually, the heme synthesis pathway consists of 7 steps. A few of those are in the mitochondria, the others are in the cytosol. I really wanted to study all of the enzymes that were involved, but after looking into it, only 5 of the enzymes are actually important for studying the USMLE. So let's start with the first one, which is ALA synthase. So here we have a duck. Actually, it's not really a duck. It's a swan. You know how in the story, the ugly duckling, he was first a duck, or at least he thought he was a duck, and everybody thought he was ugly, but then he turned out to be a swan. It's such a beautiful story. Anyway, so this duck is wearing red socks and he's smoking, something you should not do at all, especially if you're a duck. He's very agitated. He's very anxious about something, and he looks like he hasn't had any sleep, and his face is all green, so it looks like he's about to vomit. So this duck reminds me of ALA synthase deficiency. Well, actually, ALA is the Latin word for wing, although ALA in this context is not ALA per se. It's oh gosh, how do you pronounce this? Aminolevulinic acid. And it's the very first chemical in the heme synthesis pathway. It's synthesized from succinyl-CoA, and glycine. And ugly reminds me of glycine. So it's the ugly duckling wearing red socks reminds me of ALA synthase. You should be reminded that ALA synthase deficiency presents with anxiety, headaches, and other neuro disorders like paresthesias. And it also presents with nausea and abdominal pain. And, you know, our duck friend is nauseated. Several things can actually trigger ALA synthase deficiency, one of which is smoking. Other triggers can include fasting, alcohol, barbiturates, as well as, again, vitamin B6 or pyridoxine deficiency. This step is the rate-limiting step of the heme synthesis pathway, and it takes place in the mitochondria. So that's it for allosynthetase deficiency. Let's move on to the next one. So next up, we have this three-headed duck with super huge brains. I think it's like a mutant of some sort, and it's carrying with it a gun. Simply put, this three-headed duck, I think for me, represents dehydratase deficiency. You remember how in my last video I drew a hydra? Well, here again we have a hydra, a three-headed duck, and if you cut one of its heads off, more is gonna grow off. This duck represents dehydratase, which converts ALA into porphobilinogen. A deficiency in dehydratase simply results in an increase in the ALA, and it can manifest with neurotoxicity, nerve disorders, any sensory problems, and well, I represented that using the shades, and if it wasn't conspicuous enough, I represented that with a huge mutated brains. So before I forget, the gun represents lead, and dehydratase deficiency happens with lead toxicity. In a nutshell, this is dehydratase. Next up, let's go to acute intermittent porphyria. Okay, there we go. We have a cat and it's wearing mittens. Kind of reminds you of that nursery rhyme. Three little kittens, three little kittens lost their mittens. We have a cat. It's not quite a kid anymore, although it still looks kind of cute. Although it's got its tongue sticking out and something is wrong, I guess. Well, you can tell from what it's smoking and what it's drinking. Its drink isn't your typical alcohol. It's actually port wine. It's quite expensive. And this cat, it's got an ace on its hat. It's a cat in a hat. I couldn't quite decide whether I wanted clubs, spades, hearts, diamonds, and so I just decided to put an A on the hat. And this cat reminds me of porphobilinogen aminase ACE deficiency, otherwise called acute intermittent porphyria. Acute, because it's a cat, intermittent mittens porphyria. Patients with acute intermittent porphyria present with neurological deficits, neurotoxicity. They also have abdominal pain, hence the huge abdomen. They also present with port wine urine. That's why the alcohol is not your usual beer. It's actually port wine. And these patients present with port wine urine. Although I hope that this cat is drinking port wine and not port wine urine, because that would be disgusting. Acute intermittent porphyria tends to present with alcohol, with smoking. It also presents in patients who are deficient in dALA synthase. If you remember dALA synthase, I hope you remember that patients with deficiency in dALA synthase can also present with deficiency in porphobilinogen deaminase. And that's it for acute intermittent porphyria. 3 down, I have 2 to go. Okay, so here we have a bear, but it's not just any bear. You see how it has a lot of arms? It's a water bear, or a tardigrade. And it's looking at its hand, and it's really concerned because it's having all of these blisters popping up on its fur. It couldn't enjoy its tea anymore because it got concerned over its blistered skin. And oh, by the way, the tea is decaf. It's a decaf tea. And in addition to that, it seems to have a liver problem. You see how its liver is bulging through its stomach. This bear represents Porphyria Cutanea Tarda, which I remember because of tardigrade. Patients with Porphyria Cutanea Tarda have a deficiency in uroporphyrinogen decarboxylase. It's the enzyme that converts uroporphyrinogen into coproporphyrinogens because, decaf reminds me of decarb. These patients tend to have liver problems, and so they also have elevations in liver enzymes and in iron. They have these blisters on the skin, particularly on the sun-exposed areas. These patients tend to get worse with HIV infections, hepatitis infections, or with alcohol intake. So this water bear reminds me of Porphyria Cutanea Tarda. And then, finally, Do you think this looks like a puffin? Yes? No? Maybe? Please let me know in the comments. We have a puffin who is holding an iron. He doesn't know what to do with it. And he's wearing a hoodie. On that hoodie is a zipper, and the zipper is way up. In the pocket of the hoodie, there is also a pencil. The puffin seems to have enlarging brain, similar to the Hydra swans earlier. This represents deficiency in Ferrocheletase. Ferrocheletase is the enzyme that binds iron to protoporphyrin, and I remember that because this puffin is holding an iron. And we can remember also that ferrocheletase deficiency can be caused by lead toxicity. And so there's a pencil in his pocket. Drawing guns is really hard, and I didn't want to draw another one again, at least not twice in the same video. So there's a pencil in his pocket that'll remind you of lead toxicity. In this deficiency, instead of iron binding to protoporphyrin, you have zinc binding to protoporphyrin, and that's symbolized by the zipper. Z for zipper, Z for zinc, and it's way up on his hoodie. Also, these patients tend to present with neurotoxicity, and hence the huge, enormous brains. He's very anxious about it. See, ferrocheletase is the enzyme that binds iron to protoporphyrin. This reaction happens in the mitochondria. Now, when there's lead toxicity, you can have a deficiency in ferrocheletase, or at least ferrocheletase won't work the way it's supposed to, and instead of binding iron to protoporphyrin, you have zinc binding to protoporphyrin. Because of that, you get neurotoxicity. And that was ferrocheletase deficiency. And that, guys, was my video on Porphyrias. So what do you guys think? Let me know in the comments below. Tell me if you enjoyed this video and if it did help you guys with your learning. Also, let me know in the comments if you have any ideas for any future videos, any future syndromes or diseases that you would like me to draw and help you understand better. Also, while you're at it, why don't you leave a like on this video and hit subscribe and hit the bell so that you can stay tuned for future videos. Before we end, it's time for our word of the day. Again, guys, this has been Juan on JuanMD. Always remember to live life to the fullest, because you only have one life to live. I'm a different kind of guy, but I can't believe